Okay, in this video we're going to look at multiplying polynomials. We have already learned to multiply monomials using our exponent rules. This is an example of multiplying monomials, and if you'll remember, we multiply the coefficients in the front, and then the rule for multiplying exponents with the same base, or terms that have exponents in the same base, is that the base stays the same and we add the exponents. So that would be 12x to the 6th. Let's look at just a couple more that are monomials before we move on to some bigger polynomials. Negative 4c to the 5th d times 2c squared d cubed e. Okay, both of those are monomials. I'm going to multiply the coefficients in the front. That's going to give us negative 8. And for each individual variable, we're going to add the exponents. So for the c's, we're going to end up with c to the 7th, because 5 plus 2 is 7. For the d's, we're going to have 1 plus 3, so d to the 4th, and then just an e. Okay. Again, this is another example of a monomial times a monomial. This one's got some fraction coefficients. You don't do it any differently. You're still going to multiply those coefficients together. 1/3 times 3/4 gives you 3/12, which reduces to 1/4. If you think about that, that makes sense. 1/3 of 3/4. If you're taking 1/3 of something, you're cutting it into 3 equal parts. So if you cut 3/4 into 3 equal parts, how big is each part going to be? 1/4. 1/4 and 1/4 and 1/4 make 3/4. So 1/3 of 3/4 is 1/4. We'll add our exponents on our a's. That'll be, well, there's only one a, so a to the 4th. And then we'll add our exponents on our b's and get b to the 10th. Okay, so moving on from there, we're going to look at what we do when we multiply a monomial times something bigger, or two binomials, or even two trinomials. But let's start with a monomial times a binomial. Okay, 2t is a monomial, 4t minus 3 is a binomial. It has two terms. So to multiply 2t times this binomial, we're going to distribute the 2t, and we're going to multiply it times each term in the parentheses. So first we're going to do 2t times 4t, and that's going to be 8t squared. Again, because we're following that exponent rule that says when we multiply two things that have the same base, in this case the t, we add the exponents. 1 plus 1 is 2. So 2t times 4t is 8t squared. Now we're going to do the 2t times the negative 3, and that's going to be negative 6t. And this is our answer. We cannot combine those because they are not like terms. All right, let's look at another one. Here we have negative 3a squared, which is a monomial, being multiplied by negative 4a squared plus 2a minus 1/3. Okay, this is a trinomial. Again, when we have a monomial times any size polynomial, we take that monomial and we distribute it through this polynomial. And that means we take it and we multiply it times each term in the polynomial. So I'm going to take that negative 3a squared, and I'm going to multiply it times each of these. All right, so let's start with the first one. Negative 3a squared times negative 4a squared is going to be positive 12a to the 4th power, because our rule says add the exponents. All right, negative 3a squared times positive 2a. Negative 3 times 2 is negative 6. A squared times a, add the exponents, 2 plus 1 is 3. And then negative 3a squared times negative 1/3. Well, negative 3 times negative 1/3 is positive 3/3 or 1. A third of 3 is 1. And so that comes out positive 1a squared. Okay, so here's our final answer here. All right, now let's see. Do a couple more like that. Then we'll move on to some bigger polynomials. All right, negative 4a times 5a. Again, we're distributing that negative 4a through that set of parentheses. Negative 4a times 5a is negative 20a squared. Again, because 1 plus 1 is 2. And then negative 4a times negative 3 is positive 12a. All right, now let's try a binomial times a binomial. Now when we multiply binomials, we're going to use the same idea of the distributive property. We just have two things that have to be distributed. We have to take the x in this first binomial and we have to distribute it through the second set of parentheses. And then we have to come back when we're finished with that and we have to take the 3 and we have to distribute it through that second set of parentheses. All right, so let's do one thing at a time. X times x, those are both have an understood exponent of 1, and so we add them together, and x times x is x squared. Then x times 5 will be positive 5x. Now we're finished distributing the x, and we're going to come back and we're going to distribute the positive 3. So we're going to do positive 3 times x is positive 3x. And then positive 3 times positive 5 is positive 15. Now, in some problems, we'll be finished right here. But in this particular problem, if you look at what we have, you see that we have some like terms. So we'll need to go ahead and combine those. And so we end up with x squared plus 8x plus 15 as our final answer. Now, I also want to show you another way that I've seen that some people like. If you're a more visual person and you're worried about remembering what to multiply by what, you can use the box method, which is like the area model for multiplication. You can write your binomials one across the top, so x plus 3. I just like to keep the sign with the number it goes with. And then x plus 5. Okay, so we have x plus 3 times x plus 5. And then to fill in each box, you'll multiply the two terms that are on the sides of that box. So x times x is x squared in this box. A positive 3 times x is 3x. A positive 5 times x is 5x. And you can put positive on that if you want to. And then a positive 3 times a positive 5 is positive 15. Now your answer is here, but you can look and see, okay, I've got some like terms to combine. And so if I write everything that's in my boxes, I'm going to get x squared plus 8x plus 15, which you can see is the same thing that we got there. Okay, so let's try another one. Excuse me. C minus 7 times c plus 2. Okay, another binomial times a binomial. Again, all we're doing is the distributive property. We just have two things we have to distribute. We have to distribute the c through the second set of parentheses, and then we have to distribute the negative 7 through the second set of parentheses. Okay, so c times c is c squared because we add the exponents. C times positive 2 is positive 2c. Negative 7, now we're coming back. We're going to distribute the negative 7 because we're done with the c. Negative 7 times c is negative 7c. And negative 7 times 2 is negative 14. Then we look at our answer, and if we've got like terms that need to be combined, we're going to combine those, and we're going to get c squared, a positive 2 and a negative 7, is negative 5c minus 14. And if you wanted to do the box method, you could. All right, let's look at another one. Y minus 7x times y minus 10x. All right, again, I can do my distributive property. I can do my box method, whichever you prefer. I think I'll do the box method on this. I just want to show you that way a couple of times. Okay. My first binomial is y minus 7x. And my second binomial is going to go down the side, y minus 10x. All right, then I'm going to multiply what's on the sides of each square and put the answer in the square. Y times y is y squared. Negative 7x times y is negative 7xy. Negative 10x times y is negative 10xy. And negative 10x times negative 7x is going to be positive 70x squared. All right, these are like terms, so we're going to combine those when we write our final answer. We're going to have a y squared. When we combine these two, we're going to have minus 17xy and then plus 70x squared. And we should get that same answer whether we do it this way with distributive property or we do the box method. Okay. All right, let's see. Try another one. 3p minus 2 and 4p plus 1. Okay, do the distributive property this time. We're going to distribute the 3p through that second set of parentheses first. 3p times 4p is 12p squared. 3p times positive 1 is positive 3p. Okay, we're finished distributing the 3p. Now we're going to come back and we're going to distribute the negative 2. Negative 2 times 4p is negative 8p. Negative 2 times 1 is negative 2. All right, we've got some like terms here that can be combined. We're going to end up with 12p squared minus 5p minus 2. All right, let's take it one step further. We've got some big polynomials here. We've been doing binomial times a binomial. Let's look at a binomial times a trinomial. It's not really any harder or really any different. It's just longer because we've got to distribute both of these to all three terms in that trinomial. So the first thing we're going to do is distribute the 5x to all three terms. And then we're going to come back and we're going to distribute the positive 3 to all three terms. But let's start with the 5x. 5x times x squared. Remember, we're going to add our exponents. So this one has a 1 and this one has a 2. So 5x times x squared is going to be 5x cubed. 5x times positive x is 5x squared. 5x times negative 2 is negative 10x. All right, so I'm finished distributing the 5x. Now I'm going to come back and distribute the positive 3. All right, positive 3 times x squared is positive 3x squared. Positive 3 times positive x is positive 3x. Positive 3 times negative 2 is negative 6. Now I've got to do some hunting over here. I'm looking for my like terms that I can combine. I like my polynomial to be in order by descending powers of the variable. So I'm going to start with the highest power of the variable I see, which is 5x cubed. And I don't see anything I can combine that with. My x squared terms, though, I have 2 that I can combine, and those will give me plus 8x squared. Then I've got a negative 10x and a positive 3x. That's going to give me negative 7x. And then I have minus 6. So this is my final answer here. All right. Now, You can do those with the box method as well. I'll show you one on this next one, and we'll do it the box method. You just have to make your box a little bit bigger. So we have y minus 2, a binomial, times the trinomial, 3y squared plus y minus 5. So if we want to do this with the box method, we know we're going to need to put a trinomial on one side of the box. You just need to make your box longer. So one side is going to have 2, and the other is going to have 3 for a trinomial. So we'll have y minus 2 times 3y squared plus y minus 5. Okay, so let's see if we can fill in all these squares by multiplying what's on the side of each square. All right, so we've got 3y squared times y. That's going to be 3y cubed. We've got y times y. That's going to be positive y squared. We've got y times negative 5 is negative 5y. 3y squared times negative 2 is negative 6y squared. Y times negative 2 is negative 2y. And negative 2 times negative 5 is positive 10. And then you can look for like terms. I see some here, and I see some here. And all of this is part of our answer, so we have to include everything in this box as part of our answer. So we're going to have 3y cubed. We're going to combine our y squared terms. That's going to give us negative 5y squared. Combine our y terms. That's going to give us negative 7y. And then we'll have plus 10. All right, I'm going to work one more problem. A trinomial times a trinomial. P squared plus p minus 5 times p squared plus 4p minus 1. Again, there's nothing different about this except it's longer. This p squared has to be distributed through this whole second set of parentheses. Then we have to distribute the p through the whole second set. Then we have to distribute the negative 5. So it's just a whole lot of distributing. You can also do this one with a big box. If you like the box method, you just need a 3 by 3 box because you have trinomials. So I'm going to write one of my trinomials. It doesn't matter which one you put where, but if I put one of them going across the top, the other one needs to go down the side. Okay, and then we're going to multiply to get the answer in each box. So p squared times p squared is p to the 4th. P squared times 4p is 4p cubed. P squared times negative 1 is negative 1p squared. Now we're going to come down this column. P times p squared is p cubed. P times 4p is 4p squared. P times negative 1 is negative 1p. Now we're coming down this column. Negative 5 times p squared is negative 5p squared. Negative 5 times 4p is negative 20p. And negative 5 times negative 1 is positive 5. Now, it looks like we have a lot going on, but the nice thing about using the box method is that our like terms are usually on the diagonals, so you can find them pretty easily to have to combine those. All right, so we'll start from here, and our answer will be p to the 4th. We'll combine our p cubed terms, so we'll have plus 5p cubed. We'll combine all 3 of these p squared terms. Negative 1, positive 4, and negative 5 is going to end up with negative 2p squared. We'll combine our p terms. That's going to be negative 21p, and then we'll have a plus 5. And that will be our final answer.